Okay, we're going to get started now. Thank you again for joining us for today's KiloVault Best Practices for Installation and Commissioning. This is specifically around the HAB energy storage systems. I'm Jay Galassa with altE, and for our speakers today, we have Nate Dooley. Nate is a strategic account manager with KiloVault. And we have Marlon May, who is part of our technical support team for KiloVault. And they're going to be your main presenters today. I'm going to give a couple of quick intros to the first couple of slides here. So I'm going to stop this one. If you could go ahead and share the presentation, Nate, and then I'll kick things off and you guys can take it away.
Sure thing. Just give me 1 second here.
All right. Hope everybody's enjoying the conference so far. We've had 2 pretty full days of sessions. I know the open networking sessions at 3 p.m. Eastern every day has been a big hit. Hopefully you can join us with that this afternoon. If you haven't done any of these before, it's really a great way to go and get more, even more questions answered for yourself. All right, so it looks like we're ready to get going. So as I said before, this is the best practices for installation and commissioning of the HAB energy storage systems. So we've made a number of improvements of the HAB over the last few years, and I just wanted to review a little bit kind of where we came from on that. The original model, we had beta sites going out in 2018, and then we started selling it in earnest in early 2019. That was our version 1, although we didn't necessarily refer to it as version 1. That was our original model. And then we made some improvements in early 2020 with upgraded memory to support some additional features and functions. And again, version 2 was kind of how we called it internally, but we didn't actually show that so much because it was really just mainly internal changes there. And then early last year, if we go to the next slide, we made the most visible changes to the product since its original introduction. The electronics in the version 3 is essentially the same as the version 2, but it was packaged very differently based on feedback we got from a lot of our installer customers, kind of all over the place. The original one had relatively small connections for the DC input and output, the plus and minus on the side of the unit, and that limited how you could install it. So we, and plus the the size of the cables that you needed to go there, we're making it kind of a tight connection. So after hearing from a lot of you, we made changes to the case, and that allows, as I'm sure Nate will kind of go through, some of the easier to install options that we introduced last year at the beginning of the year with that version 3. And then actually right at the end of last year and certainly going forward now in this year, the version 4 looks, identical from the outside. There are a couple of subtle differences on the inside in terms of how you connect them, the different kinds of actual connectors inside. But the biggest thing is that it uses a new BMS with some new capabilities that allowed us to get it UL rated. So it's UL 1973 rated currently, and we are actively testing it for 9540 with a couple of the different popular inverters that we are typically working with. And also having 9540A testing done. That's not a specific certification, but we are having that testing done. And so I'm sure you're hearing that from other energy storage system suppliers, and we're going through the same kinds of certifications here. Just for a quick look at the version comparisons from the version 1 all the way to the version 4, all of them have this CAN bus connection that's used for inter-battery communications, allowing the batteries to, when you have more than one of them connected, allowing them to do a number of things like balancing when they're charging and discharging. In version 2, with that added memory, it allowed us to provide some additional features, including the HAB IT cloud support. And there's some important things there that Nate and Marlon will be talking about. And that also allowed inverter closed loop communications and allowed enough memory in the BMS to be able to do those. And going forward, those features are supported from V2 all the way to V4. And the wiring access panel, that lower section, that was added, and it's the same basically on version 3 and version 4. Just a couple of compatibility notes on the bottom there. The version 1, there is a newly minted firmware upgrade for version 1 units that are out in the field to communicate on the same CAN bus network with version 2 and later models. So if you are mixing a version 1 with newer models, that is now supported with this latest firmware upgrade. And the only other thing is there's a slight cable difference between the version 4 and the version 3. So, and the same cable is on version 2. And so if you're going to be using version 4 in combination with the others, there is a special cable that has a connector, a different connector on each end, so that it plugs into both in the appropriate way. So that's kind of a quick update on where we are. And with that, I'm going to turn it back over to Nate and Marlon. Take us through the rest of it.
Thanks, Jay. Can you hear me all right, everyone, as I'm talking? Well, mostly Jay, if you're on.
Yeah, no, it sounds good.
Okay. All righty. So, yeah, we're going to get right into everything here. Before we get into what's new and some of our best practices, we'll just review the technical specs here, which remain largely unchanged from our V1, V2 batteries, as many of you who are familiar with the batteries probably know. But for those that don't, it's a 7.5 kilowatt hour, 48 volt nominal lithium iron phosphate battery. It's shown here with our standard wall mount rack, coming in at about 230 pounds. And it does have integrated Wi-Fi, as Jay mentioned, and we'll talk a bit more about that in the next slides. It's rated at approximately 6,000 cycles at 80% depth of discharge, and the peak current specs are listed there: 150 amp max discharge and 120 amp max charge. A quick note on that in regards to design considerations as you're working through this with your customers, or if you're a homeowner considering the HAB for your storage system, it's really important to take into account how the battery is going to be treated, based on the size of the inverter you're working with, based on the size and quantity of charge controllers that you have. The general rule of thumb is that batteries, even lithium batteries, do like to be charged more gradually, if at all possible. One of the big selling points of lithium is that they can accept much more rigorous charge and discharge currents. So you'll see here in our warranty, we do call that out as an allowed benefit of the HAB. You can charge the battery at 120 amps continuously per battery, that is. So if you have 2 batteries in a bank, you now have 240 amps of allowable continuous charge current, and 150 on the discharge end. However, you inherently are going to get a shorter lifespan out of the battery if that is in fact how it's being treated, and our warranty is adjusted to reflect that. And that's not something that's unique to KiloVault by any means. You'll see these sort of contingencies in most, if not all, lithium iron phosphate battery manuals and warranties. But the nice thing about the KiloVault warranty is that we will support either. So if you have an application where you're less concerned about cycle life, maybe the battery is only used for backup applications, that might be a really nice excuse to take advantage of the higher charge and discharge rate, put in only one battery or two batteries and charge it really rigorously when needed, or discharge it really rigorously when the grid goes out. And then it sits, for another few months until the next utility outage. So I'd say in terms of design considerations, this is an important thing to keep in mind, that it's supported either way, but which warranty track you're on is determined by how it's being treated. And if you have any questions about that, we can talk about it more in the open networking session later. I'm happy to bounce around some use case examples to explore this further. So just a quick look back at the new features, or at the new look, I should say, of the V3 and V4 HAB. Much sleeker in my opinion, but the actual LCD panel you'll see here remains largely unchanged. So you still see the voltage, the kilowatt hour, capacity, state of charge, temperature, rough cycle count, all of that. You have your on-off switch there. Marlon, can you see my cursor on the shared screen? You give me a nod. Okay, so the on-off button here, your run light, your alarm light, and the nice state of charge indicator from across the room. If you just look over, you should get an approximation of the rough state of charge here. And then here's the new wiring access panel that Jay had mentioned previously. Also new with the new V3 and V4 cases are the integrated handles. The older versions had a handle that came attached that you would hook it onto the battery and then lift. These are nice, they're hinged and fold back down, remain inset in the battery there. So definitely nice to have these fixed handles on the side. It is a heavy battery, as we said. So people really didn't like, a lot of people really didn't like the original handle. So this was a nice development. You also get your on-off switch here below the spec placard there, and you get two different types of vents that come with it. The hotter vent, or sorry, the vented panels recommended in hotter environments, on obviously the non-vented ones in colder environments. Important to note that the HAB does not have the integrated heaters like our HLX Plus line of batteries do. So it cannot accept a charge below 32F or 0C. So always best practice to have it in preferably a climate controlled, or at the very least a nice insulated setting, or in hotter environments, a well ventilated setting to keep it cool. So something to consider again as you're working through your designs with your customers or for your own home. And just looking again at the wiring panel more closely, this is with the front panel removed here in the center. You'll see you have plenty of space to land those large DC conductors, which is nice, just because you it makes for ease of installation, but you also have conduit access on the bottom, the left, and the right. So especially if you have a utility room full of batteries, it's nice to have that flexibility where you come into the wiring compartment and having plenty of space here to make those connections. All right, so now we are going to just work through some of the notable advantages of the HAB. So this is for installers, if you can think about it as selling points for your customers, or for homeowners, reasons you might consider the HAB. The first, really, in my opinion, one of the most important is the variability in terms of how the HAB can be configured. So just a single unit for your most critical loads, for fridge, some lights and whatnot, expanded up to multiple units. I have a customer that started with just one, and then over the course of the year, as his budget allowed, he's added up to 3, 4 now, I think, and just slowly moved more circuits over from his main panel to his critical loads panel. It's a battery backup, utility interactive use case. So that's really nice to be able to start small and then expand as the budget allows. Obviously, always best to do that sooner rather than later to try to keep the batteries the same age. And it can be expanded. We support up to 14 batteries in parallel. So a total of 105 kilowatt hours in total, 80% depth of discharge is 80 or so kilowatt hours usable. So as I mentioned in the beginning, we in the past have only had our standard wall mount backplate as the mounting option, which can be a little tricky if you're lifting 230 pounds up on the wall. we're excited to now have a couple other options, one of which will be the floor mount you see here. So now the weight of the battery is supported by the floor mounted structure here, and the battery will be affixed to the wall with these two brackets. So another customer of mine actually ended up building, a couple of them have built, something similar to this because they were afraid their walls couldn't support, 5 or 6 HABs up on the walls. So it's nice to be able to not worry as much about the load bearing capability of your wall and put them on the ground without, putting them directly on the floor if there's any concern of wet basement or something like that. And then we're also going to be offering our dual floor mount, which actually has wheels and little feet here to secure it in place. Nice for originally installing the batteries, being able to move them or roll them where you want, or if you need to temporarily move them out of the way, as long as the DC conductors will allow. And you can put, like I said, 2 batteries on this facing away from each other. So we're excited to come out with those and give you all a little bit more flexibility in regards to your mounting preferences. And then we're going to look now at all of the different communication capability of the HABs. This is one of the most, if not the most important or notable advantage of the HAB line of batteries is that it is a smart battery. Aside from the BMS included in hopefully any lithium iron phosphate battery you might be considering or your customers considering, you get a lot of communication capability with the HAB. So the first would be access to the cloud service. And Jay, you said my sound's not great. Is it worth switching to Marlon, or is it enough where you can get the gist?
No, we get it just every once in a while. I don't know if it's something that's loose or whatever, but every once in a while it drops out a little bit. Okay. Sounds good right now.
All right, well, we'll go with it until it's bad. So just drop me a line if we need to switch. So the beauty of working from home is that I'm at the mercy of my local cable provider, which is not great. So everyone cross your fingers. But yeah, so we have the access to the cloud IT, and the benefit of the HAB is that you get not only your local monitoring, so even if there isn't a local area network connection at the site, the HAB has integrated Wi-Fi so that you can download the app on your mobile device and still access the local version of the app to get all of the same info that you would if you were to connect it remotely. And that's simply done by connecting to the HAB locally, selecting your local area network, and then at that point, the HAB will report securely to the cloud, and that data can be accessed anywhere so long as the Wi-Fi connection is maintained at the site. And it can also be shared, which is really nice. So if you are an installer putting the HAB in, you can share. It'll generate a unique QR code to send to your customer so they can add the HAB as a shared device, or vice versa if you want to add your installer. And beyond that, it also allows our tech support, Marlon, to access the HAB remotely, to perform diagnostics as well, and push firmware updates. So no need to download anything onto a USB and plug it in. We can push firmware updates over the cloud. So we're going to take a quick look at the mobile IT app, or sorry, the HAB IT mobile app available on the Apple and Android app stores. This has remained largely unchanged. So we'll just click through it quickly. For those who have not seen it, you just download the app, set up an account, scan the QR code on the battery. And like I said, once you are locally connected, you can connect it to your local area network if applicable. On the main basic page here, you can see the rough state of charge, voltage, amp hour capacity. You also get this on-off button here. And on the advanced tab in the middle, you get a little more info regarding your current temperature, rough cycle approximation, and then all the way over here, your event log. So any events reported by the BMS, low voltage, low temperature, and so on. And then one other very notable feature of the HABs is their InterBattery Communication network. So this is done over CAN bus, and Jay alluded to this earlier. This is something that's, I think, really unique in what allows us to support such large banks. Lithium iron phosphate cells inherently charge and discharge differently. So that's why one of the reasons we have a BMS to balance the cells within a battery. But in a lot of large banks, especially with lead acid banks, we don't have a way to balance batteries and some other lithium batteries. We don't have a way to balance between batteries. What's nice is that these batteries are able to balance one another. And I think these couple bullets here are really important for installers to understand, to be able to explain to customers, especially tech savvy customers that are really concerned with their batteries and pay close attention to them. The balancing is done upon charging and discharging. So if you have the battery sitting idly, and you notice that one battery is a few volts different, and you let it sit for 8 hours and then get really frustrated that it's still there and they're not balancing, that is normal. That is acceptable, and that's okay, because the balancing is done upon charging or discharging. So let's say battery 2 is 2 volts higher than batteries 1 and 3. What will happen is you'll actually notice the green run light will be flashing upon charging. And what that means is that this battery has pretty much removed itself from the parallel connection of batteries, and is going to stop accepting a charge until the other batteries arrive within roughly 1 volt or so. When we talk about balancing, we're not really concerned about 1 volt or a few tenths of a volt difference. And you'll hopefully see that resolve itself over time. They're probably never going to be exactly the same voltage, and that's okay. But what will happen is you'll see that as they charge and discharge, the voltages will balance out so that they're all roughly within 1 volt or so of each other. And as long as they are, that's what we care about. And again, any other questions about this as in the open networking session or in the Q&A, Marlon and I, we can work through those at that time. And the last thing, I'm going to hand this over to Marlon in a second here to just talk through some of our best practices for commissioning and whatnot. But the last major feature that Jay mentioned in the beginning that we are introducing or in the process of rolling out is our closed loop communication with the HABs. So this closed loop communication obviously refers to communication between your battery bank and your inverter. So the first example here is with the Sol-Ark 12K. We will support closed loop communications. And what this does is that it allows the BMS of the battery to communicate via Modbus directly with the inverter. So it can communicate its charge and discharge limits. It can communicate its state of charge directly to the inverter. And this is really helpful because in normal system setups, the inverter is only able to see the battery voltage at these DC terminals here, which is obviously not the exact voltage that you're going to see here because of voltage drop, obviously also depending on your wire run and how your conductors are sized. So it's nice. It adds a lot of efficiency and improved performance to the system if the batteries are able to tell the inverter directly, here is my state of charge, here is how I want to be charged, and here are the limits that you need to set for yourself to disconnect before I ever have to. So Sol-Ark, as probably many of you know who are familiar with it, can be used in DC and or AC coupled applications. The one thing that you will need to note with Sol-Ark closed loop installs as soon as that is officially supported is that there will be a new COM cable that KiloVault will be shipping to customers that have existing setups that they're waiting to enable closed loop with. And I'm going to turn it over to Marlon now for our other inverter system that we will be supporting with closed loop. And Marlon, you can take it away whenever you are ready.
All right, one moment, please.
And I can do it for you if you want. So just carry on.
I am ready when you are. So next. Oh, okay. So regarding closed loop communications, that is now available with the Schneider XW Pro. We are actually undergoing the very final stages of testing with with some customers, and it is working very, very well. So what does that actually provide? Well, as has been said, it provides state of charge control for improved state transitions. You'll have your XW Pro in state of charge control rather than voltage control in order for things to work correctly. So it does then optimizes the charging and battery protects against battery over voltage protection. I'm sorry, I just got a quick message there. So I'm sorry, let me go ahead and close that window. Okay, so it does actually provide also enhanced AC coupling controls, actually, and Eric from Schneider actually goes into that in great detail as far as the enhanced AC coupling that is provided through the Schneider Insight, and also when you have closed loop control, the XW Pro, and it is the XW Pro only. The XW Plus does not have this capability. It follows the charge and discharge limits according to the HAB's BMS. It's actually taking instructions from the BMS in order to be able to protect the battery for charge and discharge limits. And also along the same lines, the inverter protection settings are also, they're designed to trip before the BMS before BMS starts to issue commands to protect the battery itself, so that those the protection settings that you would normally program into your XW Pro, your high voltage disconnect, low voltage disconnect, current disconnects, and so on, are actually taken care of by the HAB. Next, please. So this is actually a very simple process. It's basically a couple of steps. First, you do the physical connections like we showed in the previous slide. Once that's done, you'll go ahead and do connections through the Insight home. So the last physical connection you're going to make, is to connect the Insight to the HAB itself. On version 3 HAB had a an amphenol connector. Thank you very much. Which an amphenol connector, which you which has one end is stripped, the other end has the amphenol connector that you would then connect into the connection bus of the Insight home. And we actually have the instructions as to which wires to strip and where they go. It's a little different between the Insight home in the Insight facility and gateway. By the way, the gateway is able to be used for the closed loop communications. The V4 HAB, because of we went with a more standard cable, basically it's an Ethernet connection, but you will once again have to strip off the end in order to then expose the wires that will then go into the connection block on the Insight. Next, please. So once you have done that, simply go into apologies here. You actually go into Insight, your Insight local, and actually do the configuration. Configuration is very straightforward here. Hold on here. Because basically what you'll be doing,
Yeah, I
Go
think,
ahead, please.
Marlon, it's as simple as selecting the HAB from a drop-down menu,
The menu,
right? Yeah,
exactly. Select HAB from a drop-down menu. After you have, um, we actually have the instructions on to setting the correct baud rate and so on. You select HAB from the drop-down menu and you hit apply. Then you'll see in the upper picture, you'll see in the lower right-hand corner, you see an icon that actually looks an awful lot like the Schneider battery monitor icon, but that is actually showing that it's connected to the BMS, and the name that ends up showing there, CCAN _ BMS 0. That's the name it shows up as, and that's not changeable. That name. Okay, and next, please. All right, so let's talk a little bit about some of the tips and tricks for installing and commissioning your HAB. Next, please. So best practices. So before you install, please make note of the HAB serial number and MAC address. You can either take pictures of them or just take pictures of the labels on the side of the HAB, and then you'll just go ahead and store them in a safe place. You can it might even be good to put a sticker on each HAB that's forward facing, so you know which HAB is which, and the serial numbers, just in case you need to make note of what is going on with a particular HAB. Because we also will then use, if you have an issue, we need to then we'll actually ask you for that information, including where it is in your battery bank, what address it's been given, and so on. Definitely, you need to know the environment of the installation site before you install the HAB, because of the temperature sensitivities of lithium iron phosphate batteries in general. You do want to make sure that it doesn't get too hot or too cold, which is why we include both solid side plates and vented side plates with the packaging. If it's going to get closer, getting down into the low range, closer to freezing, I would use the solid plates instead of the vented ones. So as the battery is used, it can help to keep itself warm. And also consider insulating the installation site. On the other hand, if in warmer conditions, you end up using the vented plates, and you can mix and match them so that you actually get the best result in keeping the battery at a good operating temperature. Now, when you're actually commissioning your system, you want to charge each HAB in your battery bank up to 56 volts before you put them into service. This is also very important. Next, please, Nate. Yeah, especially if you are adding a new HAB into an existing battery bank, you want to charge, not only do you want to charge the new battery up to 56 volts, you want to have the rest of your bank up to 56 volts also. That just makes it much easier for the leader in your bank to actually help to coordinate and keep your batteries as close as possible in voltage. Next, please.
Yeah, I think one
go ahead.
Note on that too is that we often will get tech support calls, as I alluded to earlier, about the balancing not working, especially if the voltage difference is really significant. It's just going to take a lot more time and effort really for the batteries to balance. So that's why this is a best practice. And I think if I were just listening to this presentation offhand, I might be scratching my head and say, well, I thought they were supposed to balance, so why the hell do I need to do this? But it's definitely best to do it from the get-go. And also important to remember that when we are selling our 12-volt batteries, which we'll talk more about tomorrow, normally we'll recommend buying a separate 12-volt charger to do the individual thing. But with your HAB, you normally, in most cases, are installing this with an inverter charger that is, in theory, already been programmed to the correct settings for the HAB. So it's really just as simple as disconnecting the other HABs that you might have in the bank from one another, and only allowing the inverter charger to bring up each HAB. So hopefully not much of a to-do, just as simple as flipping a few switches if you have individual breakers, or just use the ones on the HAB to charge each one with the integrated charger. Sorry, Marlon, that is all.
No worries, no worries. One other thing of note regarding mixing, regarding adding new HABs to an existing bank. If you are mixing HAB versions, say if you have some version 2s or version 3s, you want to add a version 4, you want to make sure that you set the most recent HAB as the leader. So if you have, things will just work out better that way. Version 4 will have a much more adept at handling a mixed a bank that's made up of mixed HABs. Next, now if you do have version 1 HABs in your bank, please contact your distributor, contact KiloVault for assistance there. We'll need to go over a few things regarding updating and so on, just to make sure that you don't run into any issues in with your battery bank. So now, if you have internet access at the installation site, then you can actually update your HABs yourself using the HAB app. In the section of the HAB where you can verify what firmware versions you are currently installed for a particular HAB. If a firmware update is available, you actually will see notifications saying that a firmware update is available, and then then at which point you can simply click that in order to trigger the downloading installation of the firmware onto that particular HAB. The tempo of firmware, I had a question earlier regarding how often firmware updates are coming. The tempo has slowed considerably as we have worked continuously on the platform. They are now with the launch of the V4, we've only had a couple of firmware updates. They are much less frequent now. Next one, Nate.
Yeah, and I forgot to include a screenshot. I don't know if you guys can see this, but I forgot to. Oh, no, not with the background.
No, you're not going to see that. Yeah.
Firmware in the yeah, it thinks I'm the camera. The firmware version in the HAB IT app is just the top 3 little bubbles or dots in the top right corner of the app. Very easy to find. Sorry, Marlon, carry on.
No worries, no worries. Some charge controllers or inverter chargers, like the Sol-Ark, for example, you need to actually put in the total resistance of your bank, in which case then you use this formula. Go ahead and, yes, so N is the number of HABs, and R is the internal resistance for a single HAB. So for example, let's say I should have stuck this in as an extra line. So say you had 2 HABs, so it would be 1/2 times 1/15, which comes out to 5.06 milliohms, which makes sense because when you have multiple circuits in parallel, their total resistance is going to be less than the resistance of any single one branch on on that parallel branch. And we see that we have had quite a few questions come in.
Let me see if I can access those as well.
The first one here from Ben, thank you very much. Ben says, well, can it accept a relay from a remote switch to turn off the battery? No, that is not a feature of the KiloVault HAB. So yeah, we have had questions about that regarding doing remote shutoff tied to an RSD system, and that is not that has not been implemented in the KiloVault HAB.
Yeah, so I mean, for that, we'd probably be looking at doing something like the remote shift breaker for midnight in the midnight birdhouse. I think that if I remember correctly from Sean White's presentation from last year, those requirements for disconnecting batteries and inverters are also going to be probably pretty fluid in the next couple of years, and we're going to start to learn more. I would highly recommend Sean's class on Friday, just a quick plug for that, if you are interested, because he definitely has a much better knowledge of the actual requirements and maybe some more insight into where they're going than Marlon or myself would. So I would highly recommend that. I will take Philip's question, Marlon.
Okay.
So that live. So Philip asked, what's the largest inverter that can be connected to one HAB? So this is going to go back to our initial discussion on charge rate. So if you think about discharge rate in terms of, or sorry, inverter size in terms of discharge rate, we could calculate the max discharge rate of the inverter by roughly dividing its maximum continuous output by the battery voltage. So let's say you had, or just look at the specification sheet for the inverter. But let's say you had a 6,800 watt inverter discharging at, about 54 volts nominal, we'll call it, or so for the HAB. 6,800 over 54 is about 125 amps. So that puts you in this top category here, maybe even pushing it a bit for a single HAB bank. So the simple solution would be to add a second HAB or just limit your maximum output on the inverter so that it never discharges. Sorry, that was for charge rate. So discharge rate, you'd still be under 150. So you never discharge above that current level. So conceivably 14 HABs in parallel would give you 150 amps times 14. And you'd be hard pressed to find a single inverter on the market that's going to exceed that. But obviously a stacked system of inverters is going to amount to some pretty high discharge currents. But that's the rough math that I would follow to figure out how your inverter size compares to your quantity of batteries required. And the other important thing to keep in mind is the charge rate as well. So if you are going to be charging continuously from 10 different Morningstar 80 amp or 60 amp charge controllers, that's 600 amps of charging capacity. You're going to need to take that into account as you're sizing your battery bank as well.
Thank you very much, Nate. So a question from James here. How often do these need to be discharged in a backup only situation to reset the state of charge? We have state of charge all over the board on one of our multi-battery installs. So we do recommend that they be given a full charge every 6 months or so. That also will tend to reset the battery's state of charge calculations. It basically the battery does kind of learn over time to actually associate a particular voltage with the state of charge, but that can drift a bit. So they do occasionally need to be told like where 100% is. So we do recommend with the HABs, as we do with the HLux Pluses, that they be given a full charge every 6 months or so. So from Philip, do they need to be vented outside, or can the battery be in a utility closet? Oh, utility closet that gets air supply and return air from the house's HVAC. Yeah, actually, that is a great place for them. In general, lithium iron phosphate batteries they like to be where we are. They putting them in an interior closet in a home is a great place for them in terms of the environment, because those are also the temperatures at which people are comfortable. And in which case, I would, for an interior place like a finished basement, I would probably start with the vented plates, in order just to see how cool it gets down there. If it gets a little chilly, then go ahead and start replacing some of the vents with the vented plates with the solid ones.
Yeah, and I think it just, this might be implied or assumed, but completely safe chemistry to have in zero off-gassing, zero risk of thermal runaway. Totally fine to have it in your bedroom if you can get over the hum from the inverter and the lights from the batteries.
Yep, that's exactly right, Nick. Yeah, that unlike other lithium chemistry batteries, there's no risk of thermal runaway with LFPs, and also unlike lead acid batteries, there's no venting whatsoever. Let's see. Do we have from James here? Does the XP MPPT 100/600 also follow the BMS charge settings? From what I remember from the XW Pro, that the XW Pro does not issue commands in order to the charge controllers. I will have to check with Eric to make absolutely sure if the MPPT 100 is also looking at the
I think, Marlon, I think I can provide a little bit of info on that. Yeah.
Thank you.
This is Jay jumping in here. Sorry about that. I think the plan within Schneider is to have the charge controllers settings automatically set by the configuration at the Insight level, but that's not available right now for the charge controllers, just for the XW Pro. So those settings would have to be set manually at this time. However, their direction is to have that integrated at a future time.
Thank you, Jay. From Giovanni, so what sort of information does the log file store? Does it require any action to activate it? No, there's no action required to activate it other than connecting the HAB to the cloud, and it contains some pretty granular diagnostic information, such as individual cell temperatures, individual cell cell voltages, what any warnings or alarms that happen to have taken place. It's very comprehensive and not really. Definitely, it's designed for the KiloVault engineers to look at, so in order to be able to help to for diagnostics.
Yeah, and Giovanni's other question was regarding setting parameters for Outback GS radians, I assume. We have a generic integration guide for the HAB, and the specification or the settings for the inverter charger are pretty much everything that you would need for the radians. So that's going to include rebulk, LVCO, IBCO, HBCO, all float and absorb voltages. The only one that you're really going to need to play with probably is the rebulk if you wanted that slightly higher or slightly lower, dependent on when you wanted to initiate a bulk charge or when you wanted a grid connect volts as well, when you wanted the grid to connect to the inverter, or sorry, when you wanted the inverter connect to the grid. So if you attended Outback's presentation, I don't know if this is for existing system or for future systems, but Outback's new inverter, the Mojave, does have, I believe, the KiloVault in the drop-down menu of pre-saved settings. So for their newer inverters, you should be able to select that. I don't know if Optics has the settings in there now for the HAB. I don't believe so. But the long answer to a short question is that you should be able to use our generic integration guide for the HAB. And I don't think there's any settings in the Outback setup that wouldn't be answered by that.
Well, let's see. Have a question here from Kurt asking if the overvoltage alarm comes on with the HAB, will the HAB turn off at some point? If the overvoltage alarm comes on, what the battery does is actually will go ahead and it actually will shut off charging. The BMS will not allow the battery to charge anymore, and it will then. So when the next discharge cycle starts, it will then. If that happens, if for some reason that battery is higher than the others in the bank, it will actually start to discharge that one, bringing it down to the others, and then they will all then start to go discharge together. That is where the balancing between the batteries actually takes place as the bank charges and discharges. Let's see, we're at 5 till. Do we want to?
Yeah, I'm just skimming through the questions here. Any of these that we can't get to, just hop into our networking session in an hour and we can go over them live. Any quick ones we can answer now. Are the RJ45 cables provided with the V4 long enough to reach stacked units, vertically stacked units with the 8 inches of clearance? Marlon, do you know how long those cables are offhand?
I don't know how long they are offhand.
Yeah, let's, James, that was from James. We'll
Yep.
We'll look at that and figure it out for you. Remind us in the open networking session there.
Oh, we did have one other question, just whether or not the plastic cover over the on-off switch was lockable. That you can put a lock on the protective plastic cover, and they're also, in addition to thumb screws, in order to hold the cover closed. And there's a hole in the clip that holds the cover closed with or without the thumb screws tightened.
Okay, guys, I think we're getting close to the time where we need to wrap up here. We want to make sure that people have time to get to their next session. So, yeah, I don't know, is there any last words of wisdom you guys have to share here?
Yeah, I'm just still looking at the questions coming in. Anyone whose questions we haven't answered, hop into the chat. I see there's a couple questions about the charge voltages, and there is a newer recommended charge voltage setting. So hop into our networking session. We can go through these.
All right, really good.
All right.
Thanks all.
Very good. Well, thank you, everybody. Thank you, Marlon and Nate. Nice job. And good luck on the rest of your sessions this afternoon to everybody attending. And we will hopefully see you at the networking session, 3 p.m. Eastern time. All right. Take care, everybody. Thanks for joining us.
Bye.
Bye.